Hello everyone, in this video we will talk about circuits. So first of all, we will revise some things, some basic knowledge and concepts, and then we will do some exercises in order for you to score a higher mark at the SAT exam, physics exam, okay? So this is our goal. First of all, we'll revise something and we'll let you know basic concepts of this chapter. So we know that the actual current flows from the negative side to the positive side because this is how electrons flow, okay? However, there is a conversion current, so let's say conversion current, and we actually write it like this, that the current flows from the positive side to the negative side. So if we have a battery like this, so if you have a battery like this is the negative side because it's shorter, and this is the positive side because it's larger. The current will flow like that, okay? So we'll mark like this. This is the current, marked with I, okay? We also have to know the Ohm's law. Okay, so we know Ohm said that voltage equals to I times resistance, okay? And voltage is measured in volts. So please do not forget this law. It's very important and it's very useful. We also have to know the difference between series, the resistors, which can be marked like this, or maybe general light bulbs or whatsoever. In this case, the current is constant and the voltage is divided. What also we need to know here in series, so here we have a battery, negative side, positive side. The current flows like this, from the positive side to the negative side. Here we have a resistor number 1. Let's say here we have another resistor number 2. So in this case, the here is also I, here is also I, so the current is constant, then the total resistance will equal to the sum of both of them, okay? So do not forget that in this case, the series one, you just add them, okay? So let's take an example. Here is 1 ohm, here is 2 ohms. The total resistance will equal to 3 ohms, okay? Very, very easy. Then in the parallel case, okay, just skip this part, the concept part, if you just want to do the exercises, but this one will be very useful. So in parallel case, the current is actually divided and the voltage is constant, okay? So here we'll take this example. Here is the negative side, here is the positive side, voltage. We have here, we have here the first resistor, the second resistor, oh sorry, my drawing is quite bad, and the third resistor, okay? So here is resistor number 1, resistor number 2, and resistor number 3. So here is look, the current will flow like this, from the negative side to the positive, from the positive side to the negative side. So this is how the current goes. However, when the current meets here, the current has to divide into two parts. Current number 1, current number 2, okay? So here is current number 2, and here is current 3, all right? Here is also divided. So let's say like this is also we will need in another laws, but it's not needed for SAT. It's Kirchhoff laws, okay? We do not need this. So what we need here is to calculate the total resistance. So we just inverse them, okay? The total resistance inversed equals to total resistor number 1, inverse resistor number 1, plus inverse resistor number 2, plus 1 over resistance number 3. So this is the formula, let's say, for the parallel case, okay? So this is what you need to know. It's pretty simple. What you also have to know is some basic formulas. I will show you right away. So we just talk about Ohm's law. Do not forget this formula, never ever. It's pretty simple. Voltage equals to current times resistance. Here we have also the power equals to I over V, okay? But we know also, so this is the formula. Do not forget this one. This is another formula. What about, we replace, so we know that I equals to V over R from the Ohm's law, okay? We know this one. So we will replace this. So power will be equal to V squared over R. What if we replace now V into I over R? from also the Ohm's law. So we will replace here V like this, and here we replace I like this, okay? Then we also know that power will be equal to I squared over R. So here are three formulas that you will never ever have to forget. So power equals to I over V, or V squared over R, or I squared over R. So these are the ones that you can easily think about, or you don't have to memorize. Just memorize this one, okay? The basic one. This one I have showed you here. All right. Let's go to the other law, the Joule's law. Joule's law. So he said that when current flows through resistors, energy is dissipated as heat. So this one is heat. Q is heat, okay? This one is heat. Equals to I squared times R times time. So do not forget this formula. Also this formula, do not forget. It's the Joule's law, okay? Do not forget this one. All right. All right, now let's do the exercises. So here we have a circuit, and it asks what current will flow through the 4. So when the switch is closed, it means that current will flow through this, okay? So this is the negative side, the positive side, and this is the current, how the current flows. Here is a parallel circuit, so we will just calculate like this. We know the Ohm's formula, which is V equals to I over I times R. This means that I equals to V over R. V is 4 volts over 4 ohms. So we can write like this if you want, which will be 1 ampere, okay? So we will mark this one. What is the total equivalent resistance for the sequence when the switch is closed? So we know this formula when the circuit is parallel, so we just replace 1 over 2 plus 1 over 4, which equals to 3 over 4. So 3 over 4 ohms, okay? What is the total power dissipated in the circuit when the switch is closed? So we know the formula that power is equals to V squared over R equals to 4 squared over 4 over 3, which will be equal to 12 watts, okay? So 12 watts. Let's just mark this up. Then the second question, here we have another circuit. So here is parallel, and then these two, this one, the total resistance with this one will be in series, okay? So just forget those now. All right, so in this case we have like this, 1 over this right here, 1 over R12 equals to 1 R1. Let's write directly, okay? So what they ask us is 1 over 2 plus 1 over 2, which will equal to 1, because half and a half equals a whole. So the total, this one will be equal to 1 ohm, okay? Then what is the voltage drop? The voltage drop means like the voltage consumed. So we will just use this formula. Oh, sorry, they say what current, okay? So current, we know that current equals to V over R. So 10 over 5, which is 2 amperes. So 2 amperes. So then it's C. Sorry, I forgot. This one means you have to really read carefully, okay? Read carefully the questions. So what is the voltage drop at the 4 ohms resistor? So we know the Ohm's law equals to 2 amperes times 2 amperes times 4 ohms, which is 4 volts. 8 volts. How much heat is generated in the 4 ohms resistor in 2 seconds? So we know this formula. Heat equals to I squared times R times T. Q equals to 2 squared times 4 times 2, which is 32 joules. All right, now let's go to the next question. We know that how much power is dissipated in the 4 ohms resistor each second. So power equals to I squared times R. So this one will be equal to 2 squared times 4, which is 16 watts, okay? 16. What is the voltage drop across the 2 ohms resistor labeled as R1? So they are talking about this one. So here we will write like this. So total voltage equals to voltage 1, 2 with the first two resistors, so this one, plus voltage 3. So 10 volts equals to voltage 1, 2 plus 8 volts. Volts number 1, 2 equal to 2 volts. So resistors 1, 2, they are in parallel, so equals to volt number 1, volt number 2, so it's 2 volts. We will circle 2 volts. Okay, the circuits shown below now are connected to the power sources that provide the same electric potential V. Which of the currents will dissipate the most power? So we know that P equals to I squared R. So the more resistance in parallel, the lower the overall resistance is. Lower overall resistance leads to more current flow. So it's B, this one. Alright, which of the circuits below which of the circuits will have the same voltage V across each one of its resistors? So we know that the voltage will be just added up, will be equal to one another. So same resistors in parallel receive the same voltage. So it's D1 and 2. Alright, so this was everything you need to know, and what and how the exercise and questions can come. This was exactly to help you achieve this goal, which we just talked about, higher mark at the SAT exam. This was our goal, and hopefully we will have achieved it. You just have to work more, and yeah, I think this is enough. This is exactly what you need to know for this chapter for the SAT. So thank you very much for watching this video, and do not forget to subscribe for more videos like this.